Good morning, everyone. We are third year, fifth semester students of CSE-C presenting our project titled Email and SMS Spam Classifier developed using machine learning. This project was carried out under the guidance of Dr. R. Madana Mohana at Stanley College of Engineering and Technology for Women. In today's digital world, spam messages through emails and SMS have increased rapidly, causing phishing, fraud, and data theft. Traditional filtering systems fail to adapt to new spam patterns and cannot provide reliable real-time detection. Therefore, there is a strong need for an intelligent, automated, and self-improving spam detection system. The main objectives of our project are to build an automated email and SMS spam detection system, to apply text processing and feature extraction, to analyze data using exploratory data analysis, to train multiple machine learning models, and to select the best performing classifier, deploy the model for real-time usage, and to implement a feedback system for continuous improvement. We used two publicly available datasets for this project. The first is the SMS spam dataset from the UCI machine learning repository, and the second is the email spam dataset from Kaggle. Both datasets contain labeled spam and ham messages. After merging and cleaning, the final dataset contains 10,327 messages. The datasets were loaded and explored using Google Colab. We imported the necessary Python libraries like Pandas and NumPy, loaded both email and SMS datasets, verified the data shape, and checked the data columns. These ensured that the data was properly structured before further preprocessing. Now, I would like to hand over the presentation to Aarifah, who will explain the data cleaning, exploratory data analysis, and text preprocessing stages of our project.
After loading the dataset, we performed data cleaning to ensure quality and consistency. We removed unused columns, checked and confirmed that there were no missing values, and removed duplicate records. A source label was added to identify whether the message belongs to email or SMS. Finally, spam and ham were encoded into numerical values for machine learning. During initial analysis, we observed that the original dataset was imbalanced, meaning the number of ham messages was much higher than spam messages. Since class imbalances can bias the model and reduce spam detection performance, we balanced the dataset by downsampling the ham messages to match the number of spam messages. This helped us achieve a fair and accurate comparison during the data analysis. After balancing the dataset, we performed data analysis using different visualizations. We analyzed the spam versus ham distribution using pie charts. We also studied word count, character count, and sentence count. It was clearly observed that the spam messages are generally longer and more structured than ham messages. A correlation heat map confirmed that message length has a strong relationship with spam detection. Before training the machine learning models, raw text messages were processed using natural language processing techniques. This includes converting all text to lowercase, tokenization, removal of stop words, and stemming using the Porter stemmer. These steps helped convert unstructured text into clean and meaningful data. After preprocessing, the text was converted into numerical features using TF-IDF vectorization. We selected the top 3000 most important features and then split the dataset into 80% training and 20% testing. This prepared the data for efficient and accurate model training. Now I hand over the presentation to Hafsa, who will explain the machine learning models, training result, system deployment, and final output.
We experimented with several machine learning algorithms to determine the best performing model. These included naive Bayes, logistic regression, SVM, KNN, decision tree, random forest, extra trees classifier, ADA boost, and XGBoost. Among all the trained models, extra trees classifier gave the highest performance with an accuracy of 99.47% and a precision score of 1. Due to its high accuracy, speed, and reliability, it was selected as a final model for deployment. When a spam message is entered into the system, the model correctly predicts it as spam. It also identifies the spam type and displays the confidence score. This confirms the high reliability of our classifier. When a genuine message is entered, the system accurately classifies it as ham, meaning it is safe and legitimate. This shows that the model also avoids false alarms. An important feature of our system is the feedback mechanism. After every prediction, the user can mark the result as spam or not spam. This feedback is stored in a file and later used for retraining the model, making the system self-improving over time. To conclude, our project successfully demonstrates the intelligent detection of real-world spam messages. The system accurately identifies different types of spams and effectively differentiates between genuine or spam messages. It achieves a high accuracy with reliable real-time prediction and also incorporates a feedback mechanism for continuous model improvement. This makes the system highly suitable for practical cybersecurity and communication platforms. In the future, this system can be further enhanced to handle more complex and modern cyber threats. It can be extended to detect advanced scams such as OTP fraud, banking phishing, and fake job offers. Additional improvements include multi-language spam detection, mobile application integration, deep learning-based spam classification, cloud-based real-time spam filtering, and integration with email, messaging, and social media platforms. Thank you for watching our project demonstration. We appreciate your time and hope you found it informative.